So I'm Frank Otto from the Advanced Research Computing Center at University College London, and I'll talk about LNet routing between Omnipath and Infiniband and our recent experiences on that. Well, very briefly, the Advanced Research Computing Center at UCL is doing quite a number of different things, which I'm not going to talk about here. One of the things is running the research computing facilities for the university, and also some national tier 2 systems. And so we have a number of, well, I guess on a big scale of things, relatively small HPC clusters, so nothing really big, nothing in the top 500. But anyway, currently all of these are using Lustre as the parallel file system. So these are the systems which are currently in use. They have been progenitor systems, but details about these have been lost to time. So Myriad is the university's cluster for high I/O, high throughput jobs, mostly single node jobs or smaller. Has about 400 compute nodes with a 100 gig Infiniband network. The Lustre is around 2 petabyte on LDiskFS. Kathleen is our other workhorse for the university. It's a cluster for highly parallel jobs spanning multiple nodes. It's a bit on the smaller side with 200 compute nodes. This one uses 100 gig Omnipath network. And we've recently replaced the Lustre file system, or still in the process of replacing it. The old one is still mounted, so people can access their old data. 1.2 petabyte using ZFS as the backend, both on the metadata and object storage. And the performance was never really great, to put it mildly. So that played a big role in replacing it. And the new Lustre system is a HPE Cray cluster store system, 2 petabyte on LDiskFS. Young is a system for the tier 2 materials and molecular modeling hub. It's basically a large version of Kathleen with 500 compute nodes, 100 gig Omnipath again. The old Lustre was similar, basically the same architecture as Kathleen ones, so relatively poor performance. And we've also replaced it with another Cray cluster store system, again 2 petabytes on LDiskFS. And we also have Michael, which is also a system for the MMM hub with another 500 compute nodes, also using Omnipath 100 gig. The old, we've been cut off a bit here, I'm afraid. So the old Lustre system is relatively small, just 0.3 petabyte on LDiskFS, running on DDN hardware. And I'm not just saying this because DDN is sponsoring this event, but this is really the system which has given us the least amount of trouble. Really very solid, nicely chugging along. But unfortunately, it reached kind of the end of life now. So in the future, Michael is using the same Lustre file system as Young. So this new Lustre system is shared between 2 clusters. Quick look at the network diagram for Kathleen, which is a bit simpler. So on the one side, we have the Cray cluster store E1000 system with the storage and the servers. Internally, it's using 200 gig Infiniband network, so we have Mellanox switches here. On the other side, we have Kathleen compute, the cluster, a couple of racks with a 100 gig Omnipath network internally. And in between, we have a pair of LNet routers, which, basically forward the traffic between the 200 gig Infiniband network and the 100 gig Omnipath network. Similar, but a bit more complicated on the Young and Michael side. Again, we have Lustre system here, internally Infiniband, and we have 2 clusters, Young with its own internal Omnipath network, and Michael with its own separate Omnipath network. Each one has a pair of LNet routers, which go back to the Lustre side. Quick word about the specs of the new Lustre system. So as I mentioned, it's a HPE Cray Cluster Store E1000. We've met that before in Michele's talk, I think. This is, well, it can scale. I think these things can scale very big, but we basically have the baby version of that with just 2 metadata servers with NVMe drives, 2 object storage servers, hard drives serving 4 OSTs, internally, as I mentioned, 200 gig Infiniband. It's basically an appliance, so it has its own management tools. So you're a bit limited in what you can tweak about the systems, but it's not all bad, especially for a team like ours where we don't really have a lot of in-house Lustre expertise. So this is the Lustre side, and the LNet routers are pretty much very basic, very standard HPE servers with dual Xenon, a bit of RAM, and 1 200 gig link for Infiniband, and 2 100 gig links each for the Omnipath side. Oh. Thank you. I should say a little bit about the LNet configuration, although I can't really say that much. The LNet routers were configured by our vendor. You can have a look at we can log into them, of course, and have a look at the NITs. So you see we have 2 NITs in the O2IB LNet side, which is the Omnipath side, and O2IB8. That's the link for the Infiniband side. The Lustre clients were configured following the vendor advice, which basically boils down to adding the roots option, setting the roots to the routers in the LNet kernel module options. I did run a bit of a LNet self-test to get an idea of the throughput. So using 8 Lustre clients with a 1 megabyte transfer size, and the numbers kind of maxed out at a concurrency level of 4. With a single server, got to around, well, quite a bit shy of 100 gig all around, especially on the write side, with 2 servers in the mix. The write load, the write performance kind of doubled almost, but the read performance kind of already reached the ceiling of what I could achieve in that. It's very well possible that I didn't do those LNet tests, self-tests, in an optimal way, because later on we also ran some Lustre IOR benchmarks, and there we reached, well, to say 2 bandwidths, at least on the right side, roughly 150 gigabit per second. So altogether, we probably would have expected perhaps something closer to 200 gig, given the architecture. But as I say, I'm not quite sure if those tests were done in an optimal way. And anyway, the actual Lustre throughput seems to be quite all right, at least for our purposes. So we started testing it, and it seemed to work quite well on Kathleen in the beginning, but on the young Michael side, where, as I mentioned, we share the same Lustre file system between 2 clusters, it became apparent that so the symptoms were just that any metadata operations that we did on Lustre, like mkdir or whatever, took a couple of minutes to complete, which is not really a useful performance. Interestingly, there were no kernel logs at all on the clients, so they all completed. It was just horribly slow. On the metadata servers, we saw some kernel logs, also saw some client evictions, and since everything seemed to work nicely on Kathleen, but not on young Michael, where the major difference is that we have a more complex routing setup. Of course, the first thing we tried is just cut off the LNet routing or restrict the LNet routing to just one of the clusters. And once we did that, then this problem disappeared. So after some discussion with our vendor, the cause was easily identified. The problem is that, well, both the Young and the Michael side, they have their own original Omnipath network, and the corresponding LNet is called O2IB, or aka O2IB0 on both sides. And because LNet peer discovery was on, that basically led to routing conflicts where the LNet routers didn't really know where to send the lustre traffic. And, well, a proper solution to this is then, of course, to renumber the LNet on one of the clusters, but that's a bit painful. So we wanted to avoid that. And the other option suggested by the vendor was to disable peer discovery, both on the routers and the E1000 system. So we did that, and it seemed to be working all right in the beginning. But it didn't really work reliable for a long time. So we ramped up our pre-production tests with the peer discovery disabled. And we basically ran IOR on a couple of nodes non-stop for a couple of days to see how stable the whole thing is. And what happened then is that we saw very similar symptoms to the earlier problem, just reappearing after a few days at most. So client I/O stalls, no progress, but also no I/O errors. And the funny thing is, this even happened, sorry. This also happened even when we restricted routing to just one of the clusters. So at that point, well, this is here one incident where we saw here IOR chugging along, reading and writing, and then at some point just it starts to stutter and performance flatlines. And a temporary fix we found is to actually reboot the LNet routers. So once we did that, then we see here, at that point we rebooted one of the LNet routers, and then the lustre traffic started picking up again. Still some stuttering until we rebooted a second LNet router around here, and then afterwards everything looks fine again. So we turn on peer discovery again, and after that, basically this problem didn't happen anymore. So everything was stable even for many days. But of course, we can't really do that in production because we still need to route to both of our clusters. So eventually we had to do the hard work and actually renumber the LNet on one of the clusters. We did it on the Michael side because it's smaller. Where we renamed it from O2IB0 to O2IB3. And eventually we could re-enable peer discovery, and, well, it's hidden here, but everything started working again. Unfortunately, that was not the end of our troubles. So another problem that we encountered is that the LNet routers, as configured, showed quite unreliable startup behavior. So what we saw one day was that we found one LNet router being unresponsive, so we rebooted it. Well, before we rebooted it, everything was fine. So because we have a pair of redundant LNet routers, lustre traffic was fine, everything was okay. So we just rebooted the second one, which was kind of offline for some reason. So it starts up, and suddenly all the lustre clients were hanging. Unfortunately, that happened after we already moved on to production. So we didn't have much time to figure out what's going on. Clients also couldn't mount lustre again. That's one thing we tried. But basically, we just turned the LNet router off again, because obviously it was causing some problems. And once we did that, the lustre started working again on all of the clients. So it's a bit funny. You have to turn things off to make things work. It's a bit of a variation on the old and trusted troubleshooting procedure, which you're probably familiar with. Okay, what's really happening here is a problem that we've been seeing with Omnipath for quite a number of systems. Namely, the Omnipath adapters take a bit of time to initialize. However, systemd, in its infinite wisdom, believes that the network online target is ready once the network device is there, even if the network device is not really working and online. So Omnipath isn't really ready, but systemd thinks it is. And then it starts starting all the dependent services, like the LNet service unit. But because OPA is not really ready, that results in incomplete configuration. So basically, it's able to set up the route to the Infiniband side, but to the Omnipath side, it's missing the routes. But eventually, Omnipath finishes initializing, so the IPs are up. And because of that, the clients try to route their traffic through the non-working Omnipath LNet router. I have to say, it's still unclear to me why the clients can't really detect that the LNet traffic is not going through and don't fail over to the other LNet router, which is perfectly fine and working. But the solution is relatively simple and stupid. Namely, we just need to add a bit of delay to the LNet startup so that it will only start up after Omnipath is properly initialized. And you can do that in the systemd universe by just adding some override config, introducing a 20-second delay. OK. Another problem that we hit after we moved to production was that our LNet routing performance was starting to deteriorate. That happens relatively rarely, so I think we've seen it 3 times in production, but with basically several weeks between the incidents. So symptoms are, again, quite similar to what we've seen before. Luster.io starts to stall just on some clients, but the number of affected clients increases over time. Again, the clients don't show any I/O errors, and eventually the I/O actually completes, but with very long delays again. So like creating a 1 kilobyte file takes more than 10 seconds and similar things. Very characteristic symptom is that when that happens, the LNet router showed this error -22 posting transmit error in the kernel logs. And the rate of those is also increasing over time as the incident progresses. And we've seen it happen either on just one of the LNet routers, but in one case also on both at the same time. And a temporary fix to that is, again, to reboot the LNet routers or to simply restart LNet. That is unloading the module, reloading it, reapplying the configuration, so you can make it a bit faster than the reboot. Once you do that, then all the Luster clients recover automatically, so you don't need to do any intervention on them. We've also added some logging of the kernel logs on the LNet routers so that we get a warning once this starts happening on the first clients. So this graph is showing basically the count of these error -22 kernel log messages over time, counting how many of them happened in the previous hour. And we see here that this is a problem started at 8 p.m. one day. It kept increasing until in the next morning we did the LNet router reboot. And all those LNet kernel errors went away. So this isn't fully solved yet, but our vendor has recently told us that they have identified a specific Luster issue, which is not, well, the fix for which is not present in the Luster version that they put initially onto the LNet routers, but it has meanwhile been backported to a newer release of their Luster version. So what we haven't yet had the time to try out. And anyway, as I say, it takes several weeks between incidents, so it will be some time before we can tell if that really fixes it. So in summary, I talked a lot about problems we found. But the truth is that for us, the LNet routing between Infiniband and Omnipath mostly just works. Performance is decent enough for our purposes. We did encounter some teething issues, which I talked about, and certainly it adds complexity. So ideally, if you don't have to do LNet routing, then it's probably good if you can avoid it. So recommendations I can give, well, first of all, it's definitely a bad idea to have two LNets with the same name in your throughout your network, because that will just lead to conflicts. And, well, just general advice, we should be monitoring everything from the start, while the cluster store E1000 system has its own monitoring, alerting built in. The LNet routers are not really part of that solution. So we basically had to add our own monitoring after the fact, and we probably should have started that sooner before moving into production. And the system, the issue that is really still nagging me is if we have this one LNet router up but not working properly, then the clients still try to use it instead of failing over to the other router, resulting in a system that actually works worse than if you have just one LNet router. So if anybody here has more experience with LNet routing and seen similar things, and maybe there's some configuration tweak that could be done to improve on that, I'll be happy to have a chat. And other than that, thanks for your attention.
Well, thank you. Lovely, thank you, Frank. Wow, your question says, where's Gareth gone with the microphone? What are we paying him for? There we go. Lovely.
Hello.
Thank you, Gwen.
It wasn't clear to me what luster versions you got on your cluster.
So the new luster is using 2.15 dot something. As I said, it's the Cray luster, which is a kind of fork of the upstream luster with their own patches. I think the original one, the .B8, is relatively on par with 2.15.2. The newer ones, I think, should be at least 2.15.4. And on the clients, we have 2.15.4 at the moment. Yeah. On the older, like the Myriad I mentioned in the beginning, that's still on 2.12.
I pulled a face there because I remember being in exactly the same situation. And 2.15.2 has some really absolutely horrific performance with Omnipath.
Okay.
Have you got some opportunities to upgrade or bug your vendor so that you can?
Okay, good to know. Thank you.
Perfect. Any more? Matt?
I was just going to ask, to the last issue you were mentioning on the LNet router, no, at the bottom, I guess it's problem 2, but about clients
So go back.
over. Yeah,
This
well,
one?
maybe not necessarily the unreliable startup part, but I was just wondering if you know, because there is like the router checker within Lustre, and I think you can configure on sort of the client side, so it'll periodically ping over LNet the routers, checking each NID is up, and you can then, at the client level, see what it sees as the state or like the health of that router's interface. So they should, if that's configured, they should be checking that. So if this has come up, but it's not actually pingable, then the client should then mark it down and then go to the other routers. That
Yeah, you mean pingable with like LNet ping?
Yeah.
Yeah. So because
But
it pings on the IP side, but it doesn't ping on the LNet side. So yeah, it should be pinged up, but maybe it's not. Maybe it's not configured correctly.
Yeah, there's like in the LNet wiki, there's a few module parameters you could. So it would just be worth checking if your vendor has those in the client module params for LNet.
So for the clients, it's basically what I showed previously, which doesn't have anything fancy in there. It was just basically,
Right, yeah,
adding
so
this part. So I guess we
if
need
it's
to
not
add
being set
something.
anywhere else, yeah, there's a few others.
Okay.
There's also one to avoid asymmetric routes as well, which I also wonder, well, just generally, I think there's a bunch that I would recommend.
Yeah, one thing I also quite not sure about is if we set it like this, then how do clients decide which LNet router to use? Will they all default to the first one? I know you can set priority on the routes, so maybe we should set like alternating priority, so half the clients have priority for one of them.
Yeah.
It will balance if there's a longer
And
queue.
Andreas, could you?
Oh, thank you.
The clients will balance across the two routers depending on if they have a long queue or one of them is down and the packets are not completing, it will use the other one.
Yeah,
Right, so
I thought so, but
it's
in
failover,
this
but-
one problem where we saw where
There's
it didn't really start up properly, then
There are some bugs in that area too. I do know one that was fixed not so long ago about it doesn't advertise its health state properly. I'm not an LNet person, but I do recall a bug in that area.
okay.
So I think one symptom might be that if some of the clients would have affinity to one router and some to another, then you might see that only half the clients are affected in what you're describing. Do you see that or not, or do you see it everywhere? Or is it
No, so at least in problem 2, where basically one came up, but it didn't really work. Basically, all the clients were affected.
it was all clients?
Yeah, that was kind of strange. But
Maybe like they tried both,
could
but as
be
soon as they
really
hit
that we should.
the bad one, they then got stuck
It's
on it.
definitely on my to-do list before Christmas to update the Luster, at least on the LNet routers.
Well, when you fixed it, actually, I think it sounds like you should come back and tell everybody how to fix it, because it sounds like this is a real concern. But I think we should probably move on. So let's say thank you very much again, Frank.